Attendees are in listen-only mode.
On behalf of RBCS, RBCS Australia, RBCS New Zealand, and Software TestWorks, we welcome everyone today to this webinar on risk-based testing, what it is and how you can benefit. I am Rex Black, President of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been both a pioneer and leader in quality hardware and software testing. RBCS has offices in the United States, Australia, New Zealand, and Sri Lanka with partners around the world. RBCS delivers insight and confidence to our clients, helping them get quality software and hardware products to market on time and with measurable return on investment. RBCS has a team of international consultants that deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. RBCS has helped hundreds of companies reduce development and support costs while ensuring the best quality products are delivered to their customers. I'm the author of 6 books on testing: Pragmatic Software Testing, Advanced Software Testing Volumes 1 and 2, Foundations of Software Testing, Critical Testing Processes, and Managing the Testing Process. I hold a degree in Computer Science and Engineering from UCLA. I am also past president of the International Software Testing Qualifications Board and the American Software Testing Qualifications Board. Before we start the presentation, a few housekeeping notes. If you have any questions during the course of the webinar, please feel free to submit them throughout the presentation at any time via your webinar interface. There's no need to ask for presentation copies. The presentation is on the web at www.rbcs-us.com. Now, if you are having problems with the audio or video, please contact GoToWebinar support. If for whatever reason you cannot get to the webinar online and you're dealing with an unreliable connection, and please download the slides from the basic library at www.rbcs-us.com, and be sure to use the telephone to connect, not voice over IP. Now, we don't really tend to see a lot of problems with this, so I don't expect that you would have any problems, but that's a fallback if you should happen to run into those. One more note before we start, something that you won't hear very often. I'm guessing you'll probably never hear me say again at the beginning of one of these webinars. Greetings from the snowy Texas Hill Country. Snow falls about once every 5 years or so here in Bulverde, and this is one of those years. So I'm sitting next to a fire, it contained in a fireplace, of course, in the RBCS office, watching snow fall outside, which is about as risk-free a setting as you can imagine. Nevertheless, today's presentation is on risk-based testing. One of the key problems in testing is how to select from an infinite set of tests a finite subset of tests that adequately mitigates the risk of quality problems after release and allows you to understand the remaining level of risk of quality problems that exist when you release. In addition, testers need to be able to allocate effort intelligently, sequence the test to find important problems first, and if necessary, reduce the test coverage to hold to hard delivery dates while not inadvertently spawning a post-release disaster. So risk-based testing provides a practical means for achieving these goals, and this webinar is about showing you how it does that. Okay, so as I said, there's an infinite number of tests that you could conceivably run. This is for any realistic size system, and that's a problem because you don't have forever to test. You don't have an infinite amount of time and resource. So one of the central challenges of testing is the selection problem. You are going to select a finite number of tests out of that infinite cloud. The question is, are you going to do it smart and in a way that that provides maximum value, or are you going to sort of wander around in the infinite cloud and beat on things until you run out of time and money, which is not very smart? I mean, ultimately, no matter what you do, if you divide the number of tests that you have run by the number of tests that you could run, which is your coverage of what you could test, that number is always going to be 0%. So you we do need to be really smart and really selective. The idea that we're going to luck upon the right set of tests to run, just find them by sheer luck from wandering around in the infinite cloud, the probabilities of that happening are extremely low. So we need a strategy. We need a smart strategy. So that's what risk-based testing is about. It's about a strategy for that selection problem, and provides a few other benefits as well. So let's define what we're looking at here. A risk is the possibility of a negative or undesirable outcome. So it's basically a bad thing that could happen. Now, there are two important elements there. One is the element of possibility. In other words, it has to be something that could happen, not something that can't happen, which is an impossibility, which we're not worried about impossibilities. And it can't be something that's certain to happen, because that's a constraint, and we're not worried about constraints here. I mean, you do have to worry about your constraints, but that's not what we're focused on for risk-based testing. Now, the other element that's essential for something to be a risk, in addition to possibility, is the element of badness, of negativity. It has to be a bad thing that could happen in order to be a risk. So, I mean, a good thing that could happen is an opportunity, but this is not about opportunity-based testing. Maybe one of the listeners today will come up with an opportunity-based testing strategy someday, but that's not what I'm talking about here. Now, specifically, when we talk about risk-based testing, the specific kinds of risks that we're focused on are quality risks. Quality risk is the possibility that the product of the system might fail to deliver one or more key quality attributes. So there's something that it should be able to do, or some way in which it should behave. In other words, some functional or non-functional characteristic of this thing that it doesn't have. System responds too slowly to user input. That's a quality risk. System calculates incorrect value for shopping cart total. That's also a quality risk. Now, when these things happen, when quality risks happen, then they endanger your ability to get the kind of quality outcomes that you want. Quality outcomes are things like satisfied customers, repeat customers, system conforming to requirements, so it's very clear what it does, absence of support calls, or at least a moderate number of support calls, profitability of the company. These are all outcomes that we get if we have quality. So ultimately, we manage quality risks for the purpose of achieving those good outcomes that we want that are associated with having a quality product. So the specific means by which we're going to enable this risk-based testing is we're going to analyze quality risks. And an analysis involves two main parts here, which I will talk about in detail. One is the identification of quality risk items, such as system response too slow to user input, and also the assessment of the level of risk associated with each quality risk item based on two factors, likelihood and impact, which we'll discuss a lot more later. And based on the risk items and their associated levels of risk, we are going to prioritize our tests, in other words, sequence them, and